this is the second part to 4.1 assignment, and I covered the graphing one over the weekend with a video so that you could graph. And the basics of the graphing is that you're going to put two lines on one equation, and our goal is to see where they cross. So the three examples here that I've already done, this one crossed at 0, -3, because we're looking for the point. So that means every answer when you do a system of equations is going to have an ordered pair. Now in this case, they don't cross anywhere, so you don't have an order pair that you can write down, so your answer is simply no solution. Now if you're asked to describe those lines, you'll say those lines are parallel, but that doesn't give you the answer. The answer is no solution. I'm not asking a description of the lines, I'm asking for what would be where they cross, and they don't, so your answer is no solution. Here the two lines cross, and their point would be -1, 1. So we also have a third possibility, and that's if one line lays exactly on top of the other one, and that was in the case 3 that I talked about. And there was no example for that one on this page, so you'll just have to refer to your first page of the notes for that. So now we're going to talk about other methods that we wouldn't have to do a graph. A graph is by far the best looking one to do because it gives you a better picture of it, and we're visual learners, so it basically explains what we're doing by picture a little bit better. But you don't always have the benefit of having a graphing calculator in your pocket or have graph paper, so it makes more sense to be able to do it algebraically. So the second method is called solving by substitution. It works when you get one of the equations so that it has a variable by itself, like right here, or this example over here. Now I did not do this example in class, but this ideally is what we would want for a situation of substitution, where we have one equation that's just simply in standard form, and the other equation that's either an x equals or a y equals, where you have a variable that's sitting out here by itself. So your blanks right here, use this method when one of equations is in an x equals form or a y equals form, so it's just got a variable by itself, and the other equation is in standard form. So substitution just means replace. So what you're going to do is replace an equivalent amount for one variable. So this says wherever you see an x, you can replace it with this expression. So you can write 4y plus 24 wherever you see an x. So what I'm going to do is go down to this equation, and I'm going to replace that x. I'm going to take the x out, and I'm going to replace it with this equal value. So I'm going to write it as 4y plus 24 minus y equals 25. Then you're simply going to solve the equation for y, but we're looking for an ordered pair, so after you get y, you've got to go back and plug it in to find x. So I'm going to distribute here. I'll have 20y plus, that's going to be 120, minus y equals 25. Collect your y's, so I have 19y plus 120 equals 25. Subtract your 120s, and you get 19y equals -95, and then you're going to divide by 19. The y value will come out to be -5, but that doesn't give us but half the answer. We're trying to locate this point, some point on a graph, so if we only have a y coordinate, we can't locate it. So you have to take the y value they give you, go back to the easiest equation, and in this case the easiest equation would be to go back and plug it in right there, because we're trying to get x. So x equals 4 times -5 plus 24. So now I have -20 plus 24. Then my x value is going to be +4. Now we need an ordered pair because it represents a dot on the graph, so you would just simply write your answer as 4, -5. Now on your homework, they're going to remind you and say type an ordered pair, so it has to be an ordered pair. Now I added this one, so let's skip over here and work on this one, because this one's the same way. It's just solved for y on this equation. So this time you're going to go replace any y values you see with this equivalent expression. So I'm going to take this and I'm going to go plug it in right there where that y is. So I'm going to take 10x plus 3, and then I'm going to plug in 2x plus 2 equals 8. Distribute the 3, so you're going to get 10x plus 6x plus 6 equals 8. So I've got 16x plus 6 equals 8. I'm going to subtract 6 on both sides. Let's make sure I'm doing this right. Yes. And then I get 16x equals 2. I'm going to divide both sides by 16. And so my x is going to equal 1/8. X is 1/8. Now that means I've got a fractional value. So if you have a fractional value here, when we're working with it this way, 1/8 would be a good fraction. You could plug it back in. Or you could do it as a decimal value in this case, and that would work out okay. So I would go back and plug in and have 10 times 1/8 plus 3y equals 8. Then I'm going to multiply through, so 10 over 8 would reduce to 5/4 plus 3y equals 8. Then I just need to simplify and get this by itself. Simplify and get that 5/4 out. So I'll go ahead and multiply by 4. So I get 5 plus 12y equals 32. Then I'm going to subtract 5. So I get 12y equals, what's that, 27? And divide by 12. So that will reduce. I can divide them both by 3. So I will get y equals, divide by 3, that'll be 9/4. So I have fractional values here, but these are good fractional values. They're 1/8, they're 9/4. So when you get fractional values that are common type fractions, it's okay to have it that way. You can then just write your answer as 1/8, 9/4. Now, since those fractional values would come out to be exact decimal values, you would be able to use that as a decimal answer. So if you do 1/8 in the calculator, get its decimal value. 9/4 in the calculator, get its decimal value. But if you do a fraction and it comes out with like a repeating decimal, it's not going to be an acceptable answer on your online homework. So this one works out pretty good. I hope that I worked everything out correctly. So this would be 3 times 2x equals 6. 3 times 2, 3 times 2. Okay, looks right. All right, now the one in the middle does not fit what our explanation says. Okay? Because it's not solved for a y by itself or an x by itself. It's actually both of them in standard form. So here's the thing. When the instructions say do it by substitution, then you have to pick what you're going to solve for. In this case, I could either get the y by itself in this one. So you're always going to hunt for a variable that has just a 1 in front of it. Or here I have an x with just a 1. So you can choose whichever one of these you want to get by itself, but you have to get one of them by itself. So let's say, okay, let's just work with the bottom one. So I want to get this x by itself. Then I can go back and substitute once I do that. So I'm going to move the 3 over and I'll get x equals negative 3y minus 9. So now I'm going to take this value that I have that's an equivalent value, and I'm going to go plug it in right there in that point. Now, if somebody else does this problem and they solve for y, it's going to get you, it should get you the same answer if you've done it correctly, because this dot that we're trying to find is like the dot on the graph up here. The dot would be a part of both of the lines. So it doesn't matter which equation you do as long as you do the math right. So now I'm going to go up to the top equation. I'm going to keep the 2. I'm going to fill in negative 3y minus 9 plus that y equals 2. So I'm going to rewrite the whole equation, but just change where the x value was. Now I'm going to distribute, so I have negative 6y minus 18 plus y equals 2. Collect your like terms. Be careful with your signs. So this will be negative 5y, and then I'm going to add the 18. So I get equals 20. Then y is going to equal to negative 4. So I get y equal negative 4. Now go back and plug it back in. But when I plug it in, you can use either equation, and you could even use this one that we changed, but you just have to pick an equation. Sometimes I choose the one that has the smallest numbers in it. Most of the time when I'm doing substitution, I'll go back and put it into this one. I know some teachers will say always go back to the original equations, because if you make a mistake going from this equation to this equation, then you're going to have it wrong when you go back. So either one, I'll probably plug into here, because that way when I do the math, I've got my answer. And negative 4 goes in there for y, and then I have minus 9. So negative 4 times negative 3 would be positive 12 minus 9. So x equals 3. Then we write our answer as an ordered pair, and an x is 3, y is negative 4. Now be careful when you type these in on your homework, because sometimes, like in this first example, we got y first. Sometimes we just make a mistake and we put the negative 5 in the front of the parentheses, and if you get them messed up and it says it's wrong, but you feel pretty certain that you got it right, to go back and check and make sure you put the x in the x spot and the y in the y spot. Okay, so this is substitution. So if it says do it by substitution and they don't give you an x equal or a y equal by itself, you have to fix it for yourself. So that'll do you for substitution method. And substitution method is one that you'll use in a lot of different ways when we're solving math. As you get into college algebra, you'll do some more stuff with substitution. Now, the third method is what we call elimination, or simply addition. It just depends on the textbook most of the time. And you're going to use this method, and this is the one that you kind of prefer and you use it the most. Both of the equations are going to be in standard form. So we got them both in standard form. The one thing you have to make sure of is make sure that your x's line up and your y's line up. So you don't want switched in one of them. So you just switch the points around, the variables around if that was the case. So here, what we're trying to do is eliminate. So the word is get rid of something. Well, we need to get rid of one of the variables so that we only have to work with one variable. So if I look at this, I need to get either both of the x's to be the same number and opposite signs, because if I add a number to its opposite number, I'm always going to come out to be 0. So if I can figure out what I need to multiply by so that these two numbers turn out to be the same number and one is the negative of the other one, then I'll be able to cancel out the expression. But you can't just multiply the front numbers, you have to multiply the whole equation. So it'd be easy to make the 3 turn into a 9 if I just multiply the bottom equation by 3. So you can't just multiply the front number, you'd have to multiply the whole thing. But I need a negative 3 so that the sign will switch for me. So if I need just the number to switch, I would just multiply by 3. But if I need the sign and the number to switch, then I would have to use a negative on the 3. So I'm going to distribute that, and I'll get negative 9x minus 21y equals negative 105. Now you can bring this other one back underneath it and have 9x plus 2y equals 10. Now when I draw my line, I'm going to be able to just add straight up and down, just like normal arithmetic. So my 9x's will cancel off. Negative 21 and a positive 2 will be negative 19. And over here I'll get negative 95. That looks familiar. We did one like that a while ago. Divide both sides by a negative. So negative 19, then y is going to this time equal positive 5. Now, you're not done, because you must have an answer right up here. You must have an answer for both x and y. So once you find one of the variables, you have to go back and plug it back in. It won't matter which of these two equations that you use, because that dot has to be for both lines. I sometimes will pick the ones that have smaller numbers in it. It just kind of doesn't really matter. But I'm going to put the 5 in where I see a y. So either I'm going to put the 5 in here next to the 7, or I'm going to put the 5 in here next to the 2. It won't matter, and you should get the same answer regardless of which one you use. I'll just go ahead and stick it in the top one. So I'll have 9x plus 2 times 5 equals 10. So I get 9x plus 10 equals 10. And when I subtract the 10s, I'm just going to get 9x equals 0. Well, we know something about any time that you get a 0 for an answer, one of these things has to be 0. Well, it isn't going to be the 9. It's got to be the x. So if you divide both sides by 9, you'll still get x equals 0. So your ordered pair answer would be 0, 5. And someone in class today noted that would be a y-intercept because it's 0, 5. Okay, so on this next one, it's a little bit different because I can't make a 4 turn into a 5, and I can't make a 5 turn into a 4. Here, I was able to just fix this bottom equation to make those two numbers match. On this one, I can't do that, nor could I do it for the 9 and the 7. So what I have to do is kind of like find a common denominator. So I'm looking for a number that both 4 and 5 would go into. I could get both of them to turn into 20. So in order to get the 4 to turn into 20, I'd have to multiply it by 5. Down here, to get the 5 to go to a 20, I'd have to multiply it by 4. So if I do that, if I multiply here by 5, that'll be positive 20. But then what happens down on the bottom one? I can't multiply it by just 4. I have to multiply it by negative 4 because I need to get the sign to change on the 5 to make it become a negative 20. So positive 20, negative 20, that means those will cancel out. Now, what would you do if you had to cancel the y's? Well, I could multiply them together. That'd tell me I could get them both to be 63. Then I could multiply the top by 7 and the bottom by 9, put a negative on it when you multiply it so that they would cancel. So when you distribute here, be careful and make sure that you go all the way through. So I'm going to have 20x plus 45y equals 5 times 19. I think that's 95. And then on the bottom I have negative 20x minus 28y equals negative 44. Now these are the equations I'm going to use to solve it, but when I have to go back and plug back in, go back to one of these originals because the numbers will be smaller. So now my 20x's cancel. 45 minus 28 would be 17y, and 9 minus 4, that'd be 51. Divide both sides by 17, so y is going to equal 3. Now if I get the sign wrong on this one, then it messes up the other one. But it's possible that I get this one right and then make a mistake on the other half. So it's possible to get half of your answer correct. And I believe on your online homework, if you do that, they'll tell you that you got half of it right, and then you just need to go back and fix the second part of it. If the first one's wrong, the whole thing will be wrong. But if you get the first one right, you might miss the second one. So I think you just have to be careful on that. So now 3, I'm going to go back and plug in, I don't know, let's see, multiplying, the numbers are not very big on either one. I'm going to plug it in the bottom one. So I'm going to have 5x plus 7 times 3 equals 11. So 5x plus 21 equals 11. Subtract 21. So I get 5x equals negative 10. Then x is going to equal negative 2. So my ordered pair, the place where these two lines on the graph would cross, the dot would be located at negative 2, 3. Now you do have a homework problem like this one. So there is a problem like this. I believe it's number 7. I'm not sure. But I did tell the students in class today but you do have one of the homework problems that's going to look like this with fractions on it. So, step 1, get rid of the fractions. Okay, if the fractions aren't there, you won't be scared of it. So the first thing we're going to do is use our common denominator and multiply it through and get rid of the fractions. So when I multiply the whole numbers, I just do that like regular whole numbers. So 3 times 2, this is going to give me a new equation, so that'll be 6x. Then when I multiply to this one, 3 times 2 would be 6 divided by 3, that'll be minus 2y. And make sure that you go all the way to the end. 3 times negative 12 would be negative 36. Now I don't have any fractions and there's nothing to worry about. So down here on the bottom, they both have 4's, so my common denominator would just be 4. Then you're going to distribute it, so this would just be 4x divided by 4 would just make 1x, or x. Then 4 times 2y would be 8y. And then 4 times 19 and divide by 4, the 4's will just cancel off right here. And then you just have equals 19. Now, what can we do to eliminate? We either need to get both of these to be 6, 1 6, 1 negative 6, or here we have a 2 and an 8. I generally would choose these two here to eliminate because the signs are already opposite for you. Anytime you have to introduce a negative sign into the problem, it always creates a place to make mistakes. So I would look and eliminate right here first. So in order to do that, I would just need to multiply the top by 4. So I'm going to put my parentheses and multiply by 4. Then that's going to give me 24x minus 8y equals, what's 4 times 36? Let me get my calculator. 144. Now draw your line. Oh, this is going to be negative 144. Okay, so your 8y's cancel, and I get 25x equals negative 125. How many quarters in $1 and quarter? Negative 5. 5 quarters. Okay, so negative 5. Now, do not go back to this fraction mess over here. Go back and choose one of the original equations, either the one with the negative 36 or the one with the 19 on it. These would be the ones that you would work with. Maybe this bottom one doesn't seem to be so much. X would just be negative 5. So I'm going to go negative 5 plus 8y equals 19. So I'm going to take this answer and go in there and plug it in. So you got directional arrows all over the place. So add 5 to both sides. You get 8y equals 24. Divide by 8. So y equals 3. So your ordered pair, the dot, would be located at negative 5, 3. So these are just solving the problems in the same way. If you were asked to graph these, you would still get the same answer. It's just a whole lot harder to graph those than it is to graph the other ones that were on the other page. So this is probably the most common method that you'll use, simply because equations appear more in standard form than they do anything else. We're going to see later how to make that work for us when we're going to do some word problems. There are two situations. Remember that one of the pictures that we had all of the cases that you can possibly have. Let me find that picture, okay? So here's our cases. Either we cross lines, so everything we just got through doing had a dot, had an answer for a dot. So it's going to look like this. Okay? Well, what happens when it in algebra when it looks like this, or what happens when it looks like this? Now, we had some situations like that when we solved regular equations, and this relates to the same thing. So let me show you two examples of what happens. When you're solving a system by substitution or addition, the case 2 and the case 3 problems are similar to what happens in regular equations. Remember the difference. A nonsense answer, say your answer all the variables fall off and you get 0 equals -2. Okay? That would be a false statement. In regular equations, we just said it has no solution. Well, that means the same thing here. It means that those lines don't ever cross, and so we don't have a point to give as an answer. Now, the other opposite kind means that we end up with 0 equals 0. That just means everything is equal to it. You know, they're all equal. That would make it be a dependent system. It's where one line lays on top of the other, and so they would have every point in common. So we have those kinds of situations again where we would have infinite solutions and no solutions. So if you have a situation where you end up with a true statement, your answer will be infinite solutions. So it would be the case where you have one line laying on top of the other, and if they don't cross each other at all, you would have a false algebra expression, and that would be a no solution problem. So here's examples of that. Now on this second equation on your notes, it has a 3 there. We need to make that an 8. Okay, so now here's one with fractions. We need to find a common denominator first to get rid of our fractions. So we need a number that 3 and 2 both go into, or just multiply them together. 3 times 2 would be 6. So my common denominator is 6. I'm going to multiply both sides by 6. Distribute it to each thing. So I'm going to have 6a minus 6 times 5 is 30 divided by 3. So 10b equals, what's half of 6? Well, that'd be -3. Okay, down here in the bottom one, I don't have to multiply through, but I'm just going to bring it down, and then I'm going to see if I can set up and solve them. So let's see, would you want to get the 10 and the 15 to be the same, or the 6 and the 9? Well, 6 and 9 both go into 18. We could get those to both be 18. 10 and 15 both go into 30, so it doesn't really matter. Let's use the front ones. So we want the 6 and the 9 to both become 18s. Well, then the top one needs to be multiplied by 3 to get 18, and the bottom one needs to be multiplied by -2 because we need the signs to be opposite. So now when I distribute, I'll have 18a minus 30b equals -9, and then I have -18a plus 30b equals -4. So now all my variables cancel, so I get 0 on the left, and over here I get -13. That's a false statement. So just like in regular equations, if it's a false statement, we say it has no solution, or we use that symbol. Now on your homework, it's going to have a drop-down menu. So it's going to say the solution is type an ordered pair. Click that dot if it's like one of these up above. If it comes out to be like this, then you're going to drop down and you're going to click the one that says there is no solution. Okay? So now here, if we try to get these two to be the same. Well, I got a negative 4 on the front. I can easily make that 2 turn to a 4 if I multiply everything by 2. So that'll give me 4x plus 2y equals negative 8. Then I'm going to bring this one and write it underneath. Then there's negative 4x minus 2y equals positive 8. So now when I add them together, they all fall out. So that's gone, so that's 0. And over here, negative 8 and positive 8 also makes 0. So now I have a true statement, which means these two lines are actually the same line. If you were to take this one and graph it on a graph, you would get an answer. Here, if you graph this one, it would graph right on top of it. So we say that they have infinite solutions because they touch in so many common dots that we can't count them all. So we have infinite solutions. You will have a couple of these kind of problems in your homework on this. So we have some of these that have graphing on it. I believe there was number 1 and 2 and 9 and 10 were graphing. A couple of them asked for substitute to be done by substitution, which I just showed you, and then you have the rest of them to be done by just doing elimination. So I wish you best of luck. I don't think this is hard. The only skills that we basically have used is add, subtract, and multiply. So you should be able to do all of those with the use of a calculator. All right, I wish you the best, and I'll see you on Thursday.